Hello everyone, my name is Harshu Predi and today I'm going to introduce you to a thing called as an API. So this is going to be a very high level and basic introduction to application programming interfaces. We're going to take a few real life examples, the communication between humans, and we're going to try to understand that example and see how it could be ported to computers and how computers communicate through APIs. Alright, to begin with, we're going to ask the question, how do people communicate in real life? Well, they communicate by talking, right? But then it sounds very simplistic when you think about communication and talking, but there are more layers of complexity associated with talking than just being able to face each other and say words. There are many issues. Well, number one, to begin with, do they know the same language? Until two people who are talking to each other know the same language, it's going to be hard for them to make sense of what they're doing. There are more issues, like where they're located. Are they near each other, or are they at a distant or a far off place? That impacts communication too. And what about the environment, right? People under different environments would communicate differently. Well, the basic is that to be able to effectively communicate, we need to have the same language, transmission mechanism, and the right environment. Well, language is really interesting because it evolved as a very standard way of communicating. I think it evolved hundreds of thousands of years back. And with the language like English, which has been accepted as a standard of communication, anybody who knows English can talk to any other person who can speak English. It's very convenient, right? And you can see examples of that happening in your daily life. We'll take the example of you doing shopping, specifically you shopping for a light bulb. So if you're shopping for a light bulb, what you do, you go to a store, you pick up a light bulb, and then you come to the cashier, and then you speak in a language. You communicate with that person. And at the end of the transaction, what happens is that you have done something by being able to communicate. You are able to transmit the data or those words or that information from yourself to that person, and that results in a transaction. So now that brings us to the question of how do computers communicate? So you may say that computers, they talk over a network. But before we talk about the network, let's ask a very fundamental question. Is it always that two computers communicate on their own, or is it mostly that humans who are using the computer result in that communication from happening? Well, it's not a trick question. Majority of the communication that you see between computers happens because a human has intervened. You click a button on a shopping website like Amazon, and some magic happens behind the scenes, and lo and behold, you have ordered a light bulb for yourself. So the reality is that most of the time humans do work on computers and they achieve something through that work, and they interact with something called as an application on those computers. So let's talk a little bit more about what are applications. It's not a complicated concept. You use applications every day in your work. Guess which is the most commonly used application? I would say it's SOAP UI Pro. I'm just kidding. It's the second most used actually. But the most of the time you use an application that is the web browser. You use web browser for browsing websites and doing a lot of stuff like checking Facebook. In this case today we're going to talk mostly about shopping for a light bulb. So you do a lot of shopping on a site like Amazon, and you use application such as Firefox or a Chrome. So great. Now what we have done is we have talked about communication between humans, and we have talked about similar communication going on between computers, and we have been able to see how these applications run on these computers, and most of the time humans are interacting with these applications, and how humans use these applications to achieve certain objectives, right? I hope you are with me so far. Okay, we talked about browsers and we talked about web applications or websites. You may call them websites as well. So what do these websites do? They primarily work over the internet, right? Well, if there is no internet, you cannot access a website. So most of the time, they are going beyond your computer and talking to some other computer over the internet to get some information for you. And the good thing is that these applications, these websites, they use a lot of APIs. So they are a good place for us to learn about APIs. So when you see a web application or a website, what you see on the website is a bunch of things. You will see images, you will see text, you would see beautiful animations, but that's just the tip of the iceberg. But there is a lot going on behind the scenes, and this is what we're going to focus on. That is essentially what you cannot see, what's happening on the website behind the scenes, where most of the magic happens. So the web application or a website, it downloads a lot of images and text onto your computer. It does a lot of other things, like when you click a button, it would do some action for you. Let's talk more about that. Alright, so let's see what happens when you get a website in front of you or a web page, and you like something that you want to buy. In this case, I'm trying to buy a light bulb, and you click the buy now button. By the way, the screen that you see in front of you, it's from my cell phone, and I did this just to make the point that it's not just computers or your laptop or your desktop that communicates over the internet, but it's also other devices like mobile phones which communicate over the internet. It's not just mobile phones, it's also smartphones, smartwatches, and other devices, like maybe if you have a Nest thermostat at your home, it also communicates over the internet. Or maybe it's a security camera that you put outside your house for enhanced security. IoT is a very important use case. IoT devices, very similar to the light bulb that I'm trying to buy. That's the reason it's very expensive. These devices also communicate over the internet. So, but what does that communication entails? What happens when they communicate? So more than communicating, these devices, computers, your cell phone, when you do some action on these applications that they're running, they trigger execution of a job. Something happens. Like for example, if you click the buy button, it's the Amazon computer on the other end that receives a signal, and it does the following. Number one, it updates your profile. In this case, when I'm buying this light bulb, it's going to update my profile. It's going to store the data that, okay, so Harsh bought a light bulb, and the next time when he comes to our website, we will show him another ad for another light bulb. Then, because I want to buy it, it also does a transaction with my bank. Okay, it also places that order on the warehouse from where this bulb would be shipped to me. All right, so just by clicking a button, communication happens between the application running on your computer and another computer which is being run by somebody else, like in this case it's Amazon, and some action happens. There could be one action, there could be multiple actions, but all these actions happen just because you interacted with the website. Okay, so keep that in mind. So you have an application, you have an action, and there is a trigger for multiple events on another computer. Now let's zoom in a little bit. So you press the button and Amazon did all these things which we talked about. I said that it's going to communicate with the warehouse to place the order, right? But then we're talking about communication by this Amazon computer. So now it has to communicate with another computer which is located in the warehouse. So that communication is another result of you pressing the button. So down the line, one action that you did on your computer triggered another action on the Amazon computer, which in turn triggered multiple actions on more and more computers, right? So now you can see this whole pattern building. So it's not just your computer that communicates with the Amazon, but it's also Amazon computer, which in turn is going and communicating with other computers, like the warehouse computer and of course the bank. So all of these communications are resulting in something being done or a data being transmitted between applications. And all of this occurs over this invisible software. Sometimes it's visible, like your web browser. Sometimes it's invisible, and it's called applications. And these applications interact with each other over an application programming interface. Okay, so remember, we defined applications before, and the Amazon computer, your computer, and all the other computers are running these applications, and all of them are talking to each other, communicating to each other through the application programming interface. It's pretty intuitive now, right? You have different applications. They want to communicate with each other and get some job done, and for that they transmit some data and information between them, and as a result, whatever tasks they want to accomplish gets done. So that is essentially basically what an API is. It connects different computers, enables transmission of data and information, and results in something being done. Okay, and as you can see, APIs enable communication not just between the computer in your hand and another computer, but sometimes the computer at the back end can also use an API to communicate with its other friends or other computers on which it wants to do some job. So now we have established that computers communicate through APIs or application programming interfaces. It's pretty similar to what humans do, and the computers do this quite frequently. They are fast, and they don't have the constraints or overheads that humans have, so they do a lot of communication between these APIs, and they do it to transmit some information, some data, and to get some job done, like ordering a light bulb or doing an online transaction. But then remember we talked about communication between humans. It was pretty much the same picture but with two different humans, and we talked about the language. The same problem exists with computers as well. If two computers are talking to each other, they need to have a common language to get something done. So when you walked into the store in our first example and you were talking to the cashier, you were speaking a common language, and that's why you were able to buy that light bulb. But similarly, computers also need a common language to be able to communicate to each other to get a job done in the right way. Okay, so they need a language. They need a standard way of communication. And now on, we're going to call this standard way of communication as standards. So there are many API standards, and I would recommend that we start with two very popular standards. They are called as REST and SOAP. Both of them sound funny, but both of them are acronyms for a very complicated set of words. So these are standards which have been set by some very smart people in bigger organizations. Most of the time what happens is that people from multiple companies, companies like Microsoft, companies like IBM, increasingly so companies like Google, they would come together and they say, hey, look, we need our computers to talk to each other, right? And because if they don't talk to each other, we can't do our business. So we need a standard way so that they can communicate with each other. So they sit down and they build these common standards, and they are industry standards. So that is what SOAP and REST is. It's a standard for communication between two computers. It's a language, all right? Other things that you might come across is the XML or JSON. Think about these as more like formats. So if you want to have an analogy from language, then they are like, how do you want to communicate a language? Maybe by writing or maybe by speaking. right? So there are different ways in which you can transmit information over APIs, and XML and JSON are formats. They are ways to structure that information, basically. So you can just understand that. Another important thing to know is that APIs, whenever they work between two different computers, of course, but it's always the case that one of the computers does most of the work and the other computer is just requesting that work to be done. So for example, in the case of buying a light bulb, when you were pressing that buy now button on your cell phone was communicating with the Amazon computer and requesting it to do something for it. That was like buy a light bulb. So most of the work was done by the Amazon computer. Okay. So on the left side we have all these computers who are requesting some work, and on the right side we have this computer which is doing the heavy lifting. It's pretty much connecting with the warehouse, ordering a light bulb, setting up a transaction. So it does a lot of heavy lifting, and we call them clients and servers. The computers which request something to be done are typically called as clients, and the computers which actually do a lot of heavy lifting, they are called as servers. So this pretty much completes the picture of an API and the way it's laid out. So you have, for an application programming interface, you basically need these components which are in front of you on the screen. You need a client, which is a computer which is requesting a task to be done. You need a server. It's another computer which has the capability of doing that task. And you need a language. That is, could be a SOAP language or a standard, as we said before, or a REST standard. Okay, so remember this whenever you're thinking about APIs, and you would understand any advanced concepts which are layered on top of this. Okay, I just wanted to add a side note to this video about, well, we have these APIs, but what is this all thing about testing an API? So why is testing an API important? Well, if you want to have your APIs work, that communication to work between two computers, you have to ensure that your server, which in this case is the Amazon computer because it does most of the heavy lifting, remember, the server has to do a lot of work, and the server has to perform correctly to the request that the client is making. So testing essentially is ensuring that when client sends some information to server, then server is able to get that job done correctly, right? For example, if after clicking the buy now with one click button, the server does everything right, but then it was supposed to return a location of the bulb where it is right now in terms of shipping, but it didn't return the correct information. But that's a problem, because you want your user to be able to see everything that they're expected to see. They want to see the location of their shipment, and that was not returned. So this problem needs to be found out early on, before even when this software or this application of Amazon is shipped. So this is a defect and this needs to be fixed. And so what testers do is they test this communication between these two computers again and again for different cases, or different data elements, different permutations and combinations of data, to ensure that everything is working fine in all the conditions. So this is the basic about testing. All right, I would like to thank you for listening in, and I hope you got some context around APIs and how they work, and you're able to relate your API communication to how humans communicate and how computers communicate. And to have do some more research, I would encourage you to look at resources on the internet. Wikipedia is pretty good to start with. So whatever you heard today in the video, things like specifications, SOAP, XML, JSON, that is pronounced as JSON, and REST. Look them up, read more about them. Hopefully you will be able to understand them more easily after having watched this video. Alright, thank you.